Welcome, parallel connection. Now, look at this diagram. Whenever you have a capacitor arranged this way, it is arranged in a parallel way. And for you to get the equivalent capacitance in this circuit, there is a way we used to do it. Now, under the course of this series, under this capacitance, a lot of calculation will come under this series. This simple thing I'm trying to introduce, if you do not understand the concept right now, you will start having issues. Now look at the board here. I said that the equivalent capacitance, which is C, which is what we want to find in this circuit, is just a combination of C1 plus C2 plus C3. So it means that in a parallel circuit, whenever I ask you to get me the equivalent or the combined capacitance, all it means is just for you to plus it. If this is 1, here is 2, here is 3, it will be 1 plus 2 plus 3, which will give you 6. Now, this is where it starts getting interesting. Are you seeing this circuit the way it's parallel, this parallel circuit? They have the same potential difference. The capacitor have the same potential difference, but it have different charges. It means the PD that is in C3 is the same PD that is in C2, it is the same PD that is in C1. But the charges that is in C1 is not the same charges that is in C2. It's not the same charges that is in C3. And that is why I said the total charges is Q1 plus Q2 plus Q3. And that C1, C2, and C3 have the same potential difference. Please write it down. It's very important. Now look at the board here. We have an example here. What is the equivalent capacitance of 3 microfarad capacitor and a 6 microfarad capacitor connected in parallel? Now, if they are connected in parallel, the answer is very simple. So, the equivalent capacitance is just 3 plus 6, which will give you 9 microfarad. And that's the answer. Can you see how easy it is? Why? Because they specify that it was a parallel connection. This is the easy part. Let's continue. Now in the next example, you can see that the diagram above, this diagram, shows two capacitors, P and Q, of capacitance 5 microfarad and 10 microfarad. Now find the charge stored in P and Q respectively. Now, remember I told you in this kind of circuit, in parallel circuit, that the potential difference are the same, but the charges, they are not the same. So it means that the charge that is here and what I say is not the same. Now remember that we said that C is equals to Q times V. So therefore, the charges is equals to CV. Now, if I want to get the charges of P, let me say QP, it will be CP times V. Remember, the voltage are the same. Now, so the CP here is 5 microfarad times 200, and that will give me 100 microcoulombs. Now, the charges of Q and small q is CQ times V, and that will give me 10 microfarad times 20, and that will give me 200 microcoulombs. And so that is the answer. Now you can see that the charges that comes into this P is 100 microcoulombs. The one that comes into this Q is 200 microcoulombs. And so you can see that automatically the charges are not the same. But you can see that I use the same voltage, meaning that the voltage are what? The same.